Hello, I'm Peter Carter. I'm making another video for the Climate Emergency Institute. Most important video because it's on the big report from the IPCC, the Intergovernmental Panel on Climate Change, their 1.5 degree C report. I'm making the video on the 22nd of March 2019. The 1.5C report was published on the 11th of October 2018. This video is of the summary for policymakers, which is the only part of the report which is approved and used by all the world governments. This report absolutely, definitely confirms that we are in a climate emergency, and a lot of people have gathered that from the report, which was a very, very good thing. I've been working on the climate planetary emergency solidly for 10 years now, so I'm very, very pleased about that. The image here is from the climate mobilization in the United States. They're running a very successful city-by-city climate emergency program. And the image here is the book I co-authored with Elizabeth Woodworth, published about a year ago, on the unprecedented crime of climate science denial. And the good part of the book, which makes up most of the book actually, Game Changers for Survival. This 1.5 degree C report, I've given it a sort of subtitle, What It Really Said. And what it really said that matters most is that we have only 1 year left, and also what it did not say. The quotes from the IPCC report are in italics. The very few comments I make are not in italics. This is a quote from the IPCC co-chair Deborah Roberts, which was a media quote with the press release of the IPCC 1.5 degree C report on the 8th of October. And her quote, "The next few years are probably the most important in human history." Now, when you watch this video, you'll realize that that is because the 1.5C report was absolutely definite that global carbon dioxide emissions have to decline rapidly from 2020. If they don't, we can expect human history to be over. The headlines, this is from the Telegraph. Earth's temperature to rise 1.5 degrees C as early as 2030 amid dire warnings from the UN Climate Panel. Here's what humanity must do immediately to prevent catastrophic climate change, according to the new UN report. The website of the IPCC, this is what you'll see on their 1.5 degree C report. The policymaker summary documents the fact, and we're going to be going through it, that a global warming of 1.5 degrees C, as everybody knows, is absolutely unavoidable. And that means unavoidably we have more often and more severe, and that includes heat waves, wildfires, droughts, forest dieback, severe storms, torrential rains, floods, diseases, including malaria, water stress and water pollution, crop yield declines, ocean heat waves. Yes, we have ocean heat waves. We have heat waves in the ocean now. Ocean acidification, ocean deoxygenation, refugees, and as everybody fears, more conflict. And we have economic decline of the global GDP, the world gross domestic product. This is a quote from that's in the 1.5 degree C report, and it was included in the press release. Limiting global warming to 1.5 degrees C would require rapid, far-reaching, and unprecedented changes in all aspects of society, the IPCC said in a new assessment with clear benefits to people and natural systems. Here's a screenshot from what you see when you go to the summary for policymakers. As I say, this is the condensed report. It's important to understand that this is the only part of the report which is approved in detail and which is used by all governments. I also want to point out there's a 3-page headline statement that you can get from this website. So that's the shortest version of the website, and it shows over and over and over the enormous benefits of limiting to 1.5 degrees C compared to 2 degrees C. 1.5 degrees C, you'll rapidly learn here, is disastrous, but 2 degrees C is total catastrophe. After 2020, it will be practically impossible to cut emissions fast enough and impossible to remove enough carbon dioxide fast enough to avoid going over 1.5 degrees C, and that also applies to going over 2 degrees C. So now I come to what is left out from this report. Fossil fuel subsidies is left out. When I say the report, I mean the summary for policymakers. And charging the fossil fuel industries the cost of their pollution, or carbon taxing, is also left out from the SPM. That's a summary from policymakers. And these are two indispensable mitigation measures. Without these, surely we all know that global fossil fuel emissions will not decline. They increased last year, 2018, by a very large amount, 2.7% in 1 year. And without these two indispensable mitigation measures by governments, they will continue, as they are today, tracking the worst case emissions scenario. So this was a terrible, terrible omission. Of course, it is in the report. It's very well expressed in the technical summary. The IPCC assessments has an SPM. That's the government's, what the governments go by. They have long chapters on each of the aspects, and they have a technical summary which summarizes the longer reports, which is much, much longer than the SPM. This rapid and far-reaching response, required to keep warming below 1.5 degrees C and enhance the capacity to adapt to climate risks, will require large increases of investments in low emissions infrastructure and buildings, along with a redirection of financial flows towards low emission investments. And this is definite, robust evidence, high agreement. Enabling this investment requires the mobilization and better integration of a range of policy instruments that include the reduction of socially inefficient fossil fuel subsidy regimes. Everybody agrees that the fossil fuel subsidies to the fossil fuel industries have to be stopped. And innovative price and non-price national and international policy instruments. I'm reading this out because it is so important to our future survival now. These would need to be complemented by de-risking financial investments and the emergence of long-term low-emission assets. These instruments would aim to reduce the demand for carbon-intensive services and shift market preferences away from fossil fuel-based technology. So that's the single most important thing in the IPCC report. But it's not recognized by the governments because it's not in the summary for policymakers. So I'm now going to be giving you quotes from the summary for policymakers. Climate-related risks to health, livelihoods, food security, water supply, human security, and economic growth are projected to increase. So risks to all of those will increase, with a global warming of 1.5 degrees C and increase further with 2 degrees C. Now, I point out that the definition of risks that the IPCC is using, and you'll see this later, is risks and or impacts. So in actual fact, these are impacts as well. These impacts will increase considerably with 1.5 degrees C, and so 1.5 degrees C, though the best we can possibly do now, is a disastrous future for a long time. Any increase in global warming is projected to affect human health with primarily negative consequences. high confidence. Scientists are all agreed on that. So to go back to the years that we have left, we have 12 years left to achieve a 50% drop in global CO2 emissions. And that comes from this statement from the SPM. In model pathways with no or limited overshoot of 1.5 degrees C, global net anthropogenic CO2 emissions decline by about 45% from 2010 levels by 2030. And this actually is in the headline statements, the three-page headline statements. So that works out at 50% from today, 2019, which means we have only 1 year left to put global CO2 emissions into a rapid decline from 2020 so that we can make a 50% cut in global CO2 emissions by 2030. So I now have to touch on carbon dioxide removal. What we are told is that all pathways that limit global warming to 1.5 degrees C with limited or no overshoot project the use of carbon dioxide removal on the order of 100 to 1,000 gigatons of CO2 over the 21st century. Another statement is that CDR deployment of several hundreds of gigatons of CO2 is subject to multiple feasibility and sustainability constraints, which basically means it's not feasible. And then we have a statement that says significant near-term emissions reductions and measures to lower energy and land demand can limit CDR, that's what the scientists call carbon dioxide removal, deployment to a few hundred gigatons without reliance on bioenergy with carbon capture and storage. And this is called BECCS, and it's a horrible idea. And it's totally not feasible, as all of the recent research published has reported. So what does this mean? Well, it means we're right on the edge of feasibility of being able to limit to 1.5 degrees C, even with immediate global decline of CO2 emissions. Because to achieve this, we have to remove some CO2, and there is one scenario which I'm going to show you now, which is the only scenario which does this by removal of CO2 by natural methods, which means agriculture and forest, which means using agriculture, regenerative agriculture, permaculture, etc., and using forestry, stopping deforestation of the tropical rainforests and afforestation, big projects worldwide. This shows what we have to do for a 1.5 degree C limit. Global CO2 emissions have to decline rapidly from 2020. This is a stylized net global CO2 emissions pathway in billions of tons of CO2. That's the billions of tons of CO2, and this runs from 1960 to 2060. CO2 emissions, this is a quote, decline from 2020 to reach net zero in 2055 or 2040. And the comment from the IPCC is faster, immediate CO2 emissions reduction limits cumulative CO2 emissions. And this is a bit sciencey, but cumulative CO2 emissions is a major determinant of global warming and on ocean heating, acidification, and ocean deoxygenation, in fact. So what the IPCC is telling us here is that we would do much better to aim for the most rapid rate of CO2 emissions decline, which is this little arrow here moving from the 2055 to 2040. This is an illustration which goes along with the image that I've just shown you. It's the first figure in the 1.5 degree C SPM I simplified this image considerably because it's really, really hard to make sense of it as in its original state. It packs so much information into one image, so I've broken it down to what is essential. And we find we have 1 year to get global emissions into rapid decline from 2020. The illustration here is called the probability of limiting warming to 1.5 degrees C, and it's observed global temperature change, which is here, and modeled responses to stylized anthropogenic emission and forcing pathways, which is here. I've taken off the lower range of the model projections to make it clearer, and nobody really can possibly believe that we're going to get a lower range, which is even better than 1.5 degrees C. That's impossible. And I've included the upper range, which is more than possible. And this is the median. This illustration, according to the report, the gray plume shows the likely warming range of warming responses in which CO2 emissions decline in a straight line from 2020 to reach zero net emissions in 2055. In Chapter 1, which I brought forward and included here, we find that 1.5 degrees C emission pathways are defined as those that provide at least a 1 in 2 chance of warming, either remaining below 1.5 degrees C or returning to 1.5 degrees C by 2100 if there's an overshoot above 1.5 degrees C, which is, again, as I say, more than a possibility. Here is the original. There's the original image from that great plume. I should also have mentioned to you that this orange line here is the global surface warming, but it's something that the scientists have been able to do for a few years. They've taken out the external extraneous influences on the global temperature increase and that leaves just our greenhouse gas emissions heat effect causing the global surface warming. And the IPCC has used this in this case. It's a much smoother line. There's much less up and downs that you normally see with the global surface warming. And it clearly shows an acceleration from 1960 up to the present time. There's a quote here that the lower the emissions in 2030, the lower the challenge in limiting global warming to 1.5 degrees C, or more likely we would be able to do that. So here's that original image. CO2 emissions decline from 2020 to reach net zero in 2055 or 2040. So that results in that, with a chance of limiting to 1.5 degrees C by 2100. So this is our only option. There are a number of scenarios in this report, but we only have one option. So we're only going to choose the best case scenario, which is given a number and letter called P1. So there it is. And this is the only 1.5 degrees C, or indeed 2 degrees C, response with proven technologies, and that is proven technologies for a foreseeable future. So here we have the billions of tons of net CO2 per year, and this runs from 2010, 2020, 2060, and goes up to 2100. The gray is emissions from fossil fuel industry. The brown is the emissions from land use, agriculture, and forestry. And this is the rapid decarbonization scenario by the IPCC. To me, it's today's response to save the future of the human race and almost all life. And what happens in it? CO2 emissions decline 45% by 2030 from 2010, or 50% from 2019. A very important thing that didn't come out, which we'll be looking at, is that fossil fuel energy is reduced by 86% by 2050 for this 1.5 degrees C limit. So that means that by 2050, the IPCC is saying that the fossil fuel industry is over and has been replaced, as we can readily do, by clean, safe, renewable, that is everlasting, non-polluting energy sources. Please note emissions of CO2 declined rapidly from 2020. I'm now just running through very quickly some diagrams which are actually very useful if you want to go back and look them over. They're diagrams of impacts at 1.5 degrees C and at 2 degrees C from this report, and they compare 2 degrees C and 1.5 degrees C. This is from Climate Analytics, showing the difference. This is from the Times of India, again showing the difference. This is very good from the Scientific American. This is from First Post, their Tech 2 page, showing again the difference. This is from World Wildlife Fund, and what they say here is extremely important. For every half degree of warming consistently leads to lower yields of crops and lower nutritional content in tropical regions. That's for every half a degree C. A terrible crime against humanity has already been committed. It's a crime against all humanity. That has already been committed by today's unprecedented levels and rates of increase of atmospheric carbon dioxide concentration and not only continued fossil fuel CO2 emissions, but a continued increase in fossil fuel CO2 emissions. Energy Post EU, this is from Carbon Credentials, and I've just taken out this from Carbon Credentials because this is very important and a really important inclusion in the 1.5 degrees C report, and that is on global GDP. At 1.5 degrees C, we have a large reduction in global GDP, 8%. That's a very big reduction in the world economy, but it's nearly double for 2 degrees C. GDP is reduced by 13%, and I'm sure it'll be much more than that in reality if everything is costed. This illustration is from The Guardian of what the IPCC called reasons for concern, or commonly known as the burning embers diagram, and this shows 10 impacts. There's 10 impacts here, and you can see the impacts at 1.5 degrees C and at 2 degrees C. We're in a very, very, very bad situation. The best we can do is hold to 1.5 degrees C, but that's disastrous for a long, long time. I want to come back now in some more detail to that best case P1 scenario. This is described as a scenario in which social, business, and technological innovations result in lower energy demand up to 2050, while living standards could rise, especially that is in the global south. It requires a downsized energy system to enable rapid decarbonization of the energy supply. Afforestation is the only carbon dioxide removal option considered for this scenario. Neither fossil fuel carbon capture storage nor bioenergy carbon capture storage are used. And there's a very good reason for that, and that is because they are more than unproven. They're totally unproven, and all the evidence we have is that they are unfeasible at all. And if we think that we can remove carbon dioxide by these measures at scale, that is completely unfeasible. So rapid decarbonization means no carbon capture storage, no bioenergy carbon capture storage. Because the IPCC says here the effectiveness of such techniques are unproven at large scale, that's for sure, and some may carry significant risks for sustainable development. And that applies to the so-called BECS, bioenergy carbon capture storage, and the IPCC in this report is backing away from the idea of bioenergy carbon capture storage and moving more to supplement the natural methods, regenerative agriculture, stop deforestation, afforestation worldwide, with direct air capture, sucking CO2 out of the air, making it into chemically converting it into a solid or a liquid. But even that will be quite very limited to the amount that we can remove. I'm now showing you this part of this illustration, this whole illustration, which is in the 1.5C report, because this did not, the media did not report on this. The IPCC for the first time here does a very useful thing. It gives us specific numbers. And when we look at IPCC numbers, we know they're all overly conservative because of the influence of the policymakers and the requirement of total agreement. So bear that in mind. But they do give us numbers this time for coal, oil, and gas. How much of those fossil fuel energies, at a minimum, would need to be reduced at 2030 and at 2050. Here I've just taken that, and you can see coal, oil, gas, and primary energy from coal in 2030 percent compared to 2010. So these figures you've all got to increase. And so that's 2030 and that's 2050. So there's oil. 2030, 2050, and natural gas 2030, 2050. Remember that natural gas is mainly methane. Natural gas is mainly methane, and it's impossible for the industry to stop all fugitive. That's all leaks from the natural gas industry. So the more gas is extracted, particularly fracking, and the more the distribution pipelines, the more methane you're going to get, as well as CO2, because natural gas is a fossil fuel which does emit CO2 when it's burnt, albeit at about half what coal would be emitting. So here we go. Coal, by 2030, a 78% reduction. 2050, a 97% reduction. Oil, 2030, a 37% reduction. 2050, an 87% reduction. And natural gas, 25% reduction 2030, 74% reduction 2050. So this is the phasing out of the fossil fuel industry, which is essential for our survival and the survival of most of life, land and oceans, on this wonderful planet. I put this in to even further reinforce the message that global emissions must decline by maybe from 2020, but we only have 1 year left. Now, these are all the authoritative reports and the top scientific projections, model projections from all of these sources, and they all show the same thing. They all show that global emissions have to decline at the very latest from 2020. This is the overwhelming scientific fact that global emissions must go into decline by or from 2020, which we can readily do. We've got all the technology that we need. It is being rapidly developed. And all we have to do to get that market shift that was referred to in the technical summary is for governments to be forced to immediately stop subsidizing the fossil fuel energy. And the market is so sensitive and powerful, and we have a situation in which now renewable energy is on a competitive level playing field with coal and oil, despite subsidies, that just taking those subsidies away would be a massive economic shift of investment away from the planet-killing fossil fuel industries and into the planet-saving, future-saving renewable energy, brilliant industries. We're now going to look at the original illustration that I showed that was put out in a very easy way to understand by The Guardian. And this is what the IPCC call their reasons for concern. and it's commonly called the global warming embers, and we've had this since 2001, the third assessment. Now I've cut this down here. I've just left it up to the present time, which is 2006-2015 average here. And just to show that this red is severe and widespread impacts are detectable, and this yellow is impacts are detectable, right? So here, warm water corals, we already have severe and widespread impacts detectable. We have impacts detectable for what they call a category of unique and threatened systems. These are just general categories. What these are the most vulnerable populations and ecosystems. So we've already got impacts. And we all know that we have impacts practically everywhere where human beings live of increasing extreme weather events. So we've got those detectable. And this is the big one. This is what they call large-scale singular events, which of course are planetary tipping points. But we've already got impacts detectable. This is the whole image. It's 5 broad categories of impact points. These are the dependence of risks and or impacts associated with the regions of concern. And so what these really are is that they're impacts is what they are, by the way. So here we have threatened and unique systems. These are the most vulnerable human populations and the most vulnerable ecosystems. And they get up into the red, the darker red at 1.5 degrees C. Extreme weather events are most damaging to populations and to their crops. And at 1.5 degrees C, we're way into the red. Distribution of impacts is inequality. The global aggregate impacts, which is the economic. Again, this is wrong. They're applying the perverse standard market economics here, which by no means include all the costs of these extreme weather events, for example, and by no means includes the benefits of switching to renewable energy. But the 1.5 degrees C assessment did actually acknowledge that there are very, very significant costs at 1.5 degrees C, which almost double at 2 degrees C. So here's the big one. Here is what they call large-scale singular events. These are planetary tipping points. And we are going into the red at 1.5 degrees C. So these are massive, irreversible, total planetary catastrophe impacts. So here's what here's the legend on how you interpret it. The 1.5 degrees C report gave us further impacts on what they call various natural managed and human systems. So they give us, again, coral reefs. Well, warm water coral reefs are doomed. They give us the Arctic change, including Arctic sea ice area, very much into the red at 1.5 degrees C. Coastal flooding, that's obvious. Fisheries, very, very bad at 1.5 degrees C, very bad. Terrestrial ecosystems, bad at 1.5 degrees C and getting rapidly worse. I would say this is overly conservative on ecosystems. Fluvial flooding, river flooding, going into the red at 1.5 degrees C. Crop yields is going into the red after 1.5 degrees C, but we've already learned that at 1.5 degrees C, the crop yields of the tropical regions and African regions will be severely impacted and will be reduced even below the baseline of today's production. Having said that, this shows globally averaged crop yields, which means that at 1.5 degrees C, we can expect that global food production will be in decline, and at 2 degrees C, world food production will be in severe decline. Which brings me to a crucial fact that applies to all of these impacts. What do we have to do to prevent crop production impacts of 2 degrees C? Well, we have to limit global warming to 1.5 degrees C. We have to assume, due to the large inertia of the climate system, due to the vast amount of heat stored in the oceans, that there's always more heat in the climate system than registers as a global surface warming. For example, 2.4 degrees C extended to 2300 becomes 2.8 degrees C, and 2.8 degrees C extended to 2300 becomes 4.2 degrees C. I'm talking here about food security for the future of humanity. I'm looking at a time horizon of many hundreds of years. And we also, over that period, would have to factor in the extra global warming from amplifying climate system feedback emissions. Heat-related morbidity and mortality. This is heat increase due to linear projected global surface warming. Extreme heat events, which will increase in incidence, severity, and duration, will be extremely severe at 1.5 degrees. This takes us back to crop yields, because the reduction of crop yields are projected by linear projecting models, and these do not account for the extreme increase in heat waves I've just mentioned, which will episodically cause devastating damage to crop yields in many, many regions of the world at 1.5 degrees C. I'm bringing this forward now from the part 5 of the report. This is table 5.2. I'm bringing this because here is where the IPCC says 1.5 degrees C is not safe. Warming of 1.5 degrees C is not considered safe for most nations, most communities, most ecosystems, and most sectors. Significant risks, which means more impacts to natural and human systems, are projected and will occur compared to what we have at 1 degree C. So they give us the numbers for coral reefs, the numbers for biodiversity, the numbers for poverty, and the numbers for human health, and they're all terrible. And so biodiversity, double at 2 degrees C. Coral reefs we've lost. Poverty, 3 times at 2 degrees C. And human health impacts deaths and diseases and injuries and deaths and accidents from extreme weather events and flooding, etc., double at 2 degrees C. These are some quotes which I'll just pick out the things that are particularly sort of interesting from the summary for policymakers. Arctic warming is 2 to 3 times higher than warming the global average. It's no longer only double. It's 2 to 3 times higher, so that is right. Trends in intensity and frequency of climate and weather extremes have been detected over time, during which only about 0.5 degrees C of warming had occurred. Warming from anthropogenic, that's human-sourced emissions, since the pre-industrial period to the present, the warming will persist for centuries to millennia. The warming will last for over 1,000 years, which will continue to cause further long-term and increasing changes, impacts in the climate system. And of course, the obvious one is sea level rise, but there are others that also are very, very important. For example, feedback emissions will continue as long as there's global warming, because feedbacks, the emissions of carbon, for instance, from permafrost, and from drying and droughting forests, feedbacks are increased by the global temperature as well as the duration of that global temperature. So here it says some impacts are long-lasting or irreversible, so long-lasting and irreversible, really. And the impacts risks depend on the rate as well as the duration, which I've just measured, as well as the peak warming. The rate is really, really important. in determining how severe the impacts. In, say, more hot extremes in most inhabited regions, high confidence, heavy precipitation in many regions, and the probability of drought and precipitation deficits in some regions. The probability is pretty definite, and the regions are very large. We have sea level rise will continue beyond 2100. Like most of the IPCC assessments, the temperature projections only take us up to 2100. So in general, the impacts that you've just seen are only up to 2100. They don't stop at 2100. Marine sheet, this is important, Antarctica and or irreversible loss of the Greenland ice sheet, multi-meter sea level rise, and these instabilities could be triggered at 1.5 degrees C. So at 1.5 degrees C, the massive Greenland ice sheet may be committed to slowly slide into the ocean and add to sea level rise. Of course, small islands, but also low-lying coastal areas and also deltas, very important for agricultural regions. And here we have the species numbers. We are already in the sixth mass extinction. And at 1.5 degrees C, that's going to be greatly accelerated. So these percentage increases in species extinction comes on top of the sixth mass extinction and further accelerates it. And 2 degrees C, the numbers are double compared to 1.5 degrees C, and a absolute total catastrophic acceleration of species extinctions. When we talk about global warming, we should remember we're also talking about ocean heating and ocean acidification. So the higher the global warming, because it's coming from mainly carbon dioxide, the greater and the faster is the ocean acidification, because ocean acidification is accelerating. And so therefore, 1.5 degrees C would reduce the rate of increase in ocean temperature, and the increases in ocean acidity, and the increases in ocean and the decreases in ocean oxygen level in the deoxygenation. So we're going to have more ocean temperature heating, more ocean acidification, and more deoxygenation of the oceans at 1.5 degrees C, and much more at 2 degrees C. Coral reefs we've mentioned. The level of ocean acidification at 1.5 degrees C will amplify the adverse effects of ocean warming, and even further amplify at 2 degrees C. Both 1.5 degrees C and 2 degrees C will impact the growth, development, calcification, survival, and abundance of a broad range of marine species, from algae to fish, absolutely catastrophically devastating to the oceans, to life in the oceans. And the impacts of climate change in the ocean are already increasing risks to fisheries, and that includes open ocean fisheries and aquaculture. The recent research shows a decrease in the global annual catch in marine fisheries of about 1.5 million metric tons for 1.5 degrees C, and double 3 million tons at 2 degrees C. So I think we all know we're already fishing the oceans out, and humanity has to stop doing that. But if we don't, at 1.5 degrees C, the impact on the fisheries will really wipe out the world's fisheries and the fish in the sea. Hard to believe, but this is what we're looking at. So now we come to risk to health. We have, and we've seen this already, any increase in global warming is projected to affect health, to damage human health. And this is very, very important. Risks from some vector-borne diseases, such as malaria and dengue, are projected to increase with warming from 1.5 degrees C to 2 degrees C. So malaria is the biggest killer of diseases and health impacts on the planet. And dengue, the problem with dengue is it's a horrible, similarly horrible disease, and we don't have a treatment for it. This is the change of reduction in crop yields and detailed in areas. So we are seeing we are committed to major crop yield declines at 1.5 degrees C, and water stress, a huge increase at 1.5 degrees C that we'll come to, and even more. We're talking billions of people here at 2 degrees C. Food security being obviously so absolutely crucial with respect to climate disruption, I brought forward from Chapter 3 some numbers for the science projections. And this says a significant reduction has been projected for the global production of wheat, 6 to 2.9%, so that's up to 8.9%. Rice, 3.2 plus or minus 3.7%, so that's up to 6.7% for rice. And soybean by 3.1%, and that is for each degree Celsius increase in global mean temperature. So for each degree Celsius, wheat up to 8.9%, rice up to 6.7%, and soybean 3.1%. Similarly, the text says, research indicated a significant reduction in rice yields for each degree Celsius increase by about 10.3%. in the greater Mekong sub-region. That's huge. The text ends, large rice and maize yield losses are expected in China owing to climate extremes.